Unit 1, Notes 1.3. So these are the notes for Unit 1, Day 3. In this lesson, we are going to be talking about function operations and composition of functions. Let's start off by talking about some vocabulary that you're going to hear us using over and over. So a relation is a set of ordered pairs, or it is a rule that produces one or more outputs for each input. So every x has at least one y. Okay, let's drill down and get a little bit more specific. A function is a relation that gives a single output for every input. So basically, if you wanted to sum it up, a relation is where x can repeat. But for that relation to be a function, x cannot repeat. So that's what we mean by the difference between a relation and a function. So in other words, in a relation, you can have 2, 4, 2, 5, 2, 6. However, in a function, you can only have 1, 2 going to 1y. So x cannot repeat in a function, x's can repeat if it's just a relation. So in order for a relationship to be a function, every input must have an output. So every x must have a y. The next thing is that two different inputs can have the same output, meaning y can repeat as much as you want. Y is totally okay with repeating. However, one input can only have one output. So x's cannot repeat, but y's can. But really, all you need to focus on is when you're determining if it's a function, is looking to make sure that the x's don't repeat. Let's talk about how we test if a graph is a function. When we test to see if a graph is a function, we use the vertical line test. So the vertical line test says, if it is possible for a vertical line to intersect a graph at more than one point, then the graph is not the graph of a function. Meaning, as I move a vertical line across my graph, if that vertical line touches my graph in 2 different places or more, it's not a function. Now, these next few slides you don't have to copy. These are just for a visual representation. So let's look at this. Using the vertical line test, let's see if this is a function. So take a guess. What do you think? And let's see if you're right. We see that our graph touches our vertical line at 2 places. So therefore, this is not the graph of a function because it fails the vertical line test. What do you think about this guy? Let's check. Did it pass? It sure did, because as that vertical line moved across my graph, it only hit my function once at each point. What do you think about this guy? Look what happened here. It touched 1, 2, 3 different places. So therefore, that is not a function because it failed the vertical line test. How about this guy? Wah, wah. Again, it touched our graph in 2 different places. So no, because it failed the vertical line. Let's try this one. It only touched my vertical line once in each place, but this looks like my graph that we just did. We have there and there. Why didn't it stop there? Because if you look at it, this is an open circle right here. So this guy, he has an open circle, meaning it goes to that point, but it does not include that point. Think about your inequalities when you graphed one variable inequalities and you'd use an open circle versus a closed circle. So the open circle means we don't count that point, but the closed circle does. So he does not count as a point. So that's why it passes the vertical line test. Let's look at this slide. So we're going to evaluate f of x equals x squared if x equals 3 and x equals negative 3. So if I plug in positive 3, I get 3 squared. If I plug in negative 3, I get negative 3 quantity squared. Well, 3 squared is 9. Negative 3 squared is 9. And you're probably thinking, well, like that was pointless, but it's really not. There was a purpose behind this because we see a lot of you guys when you enter this into your calculator, like if you're plugging in negative 3 and you go to square it, you treat it just like that. Well, according to order of operations in PEMDAS, it says we do exponents first. So that would give me 3 squared is 9, and then I would apply the negative. So the point of this is always use parentheses when you're plugging in a value into an equation. So always, always, because you can see that this right here is the correct answer. That would be the incorrect answer. So let's look and let's revisit the linear equation. So the linear equation, we know that's y equals mx plus b. However, let's look at the most basic linear equation there is out there. That's y equals x. So now we're going to create a table of values. Now, you're going to learn this more when we get to Unit 3. You're going to learn that we always graph using those 5 x's. Negative 2, negative 1, 0, 1, and 2. And those are going to be referred to as our Fab 5. Okay, so those 5 x's, negative 2 to positive 2, those are going to be referred to as our Fab 5 from here on out. So when I plug negative 2 in, I get a negative 2 out. When I plug a negative 1 in for x, I get a negative 1 out. Same with 0, same with 1, same with 2. So this is the most basic linear function you can have. So let's look at a graph. We're going to graph those points and then connect the dots. So that's what the graph of the most basic or simple linear equation looks like. So let's answer the question. Is it a function? Well, it passes the vertical line test, no x's repeat, so we're going to say yes. And so, like I'm trying to say, we call this the linear parent function. So this is going to be something that you want to remember, the linear parent function, because it has a slope of 1 and it has a y-intercept of 0, the linear parent function. Now we're going to look at some graphs and we're going to write the equation of the line and determine if it's a function. So this is a horizontal line, my slope. Now let's think back. What is the slope of a horizontal line? It's rise over run, but there is no rise, so my rise is 0. 0 over anything is 0, so my slope is 0. Now when I look at the equation, if the slope is 0, 0 times anything is 0. So that's just going to be y equals b. Well, my y-intercept is 4, so it's going to be y equals 4. If it's a function, I'm going to pass that vertical line through it and it's only going to hit it once. Does that happen here? It sure does. It passes the vertical line test. There's only one x for every y. So yes, it is a function. Now let's talk about domain and range. Now the domain, if we go from smallest x to biggest x, you're going to see that it's coming from negative infinity and it's going to keep going all the way to positive infinity. So that is my domain. My domain is negative infinity to positive infinity. But here's where the range is going to get a little bit different, okay? In this case, my range, they're all 4s. When you look at the range, all of my y's are 4s. So I'm just going to put 4 in a bracket because 4 is the only value I have for y. Let's look at another one. This is a vertical line. What is the slope? Well, the slope is undefined because you don't have any run. It's going to be anything over 0. Anything over 0 is undefined. But it does have an equation, but instead of y equals a number, it's going to be x equals a number. So it's going to be x equals -5. Is it a function though? And the answer to that is no, because it fails the vertical line test because it is in of itself a vertical line. But let's talk about the domain. So the domain, if I'm looking at this guy, I only have one x. I only have one x, and that x is -5. So I write -5 in brackets because I can actually touch it, and every x on this line is a -5. But let's talk about range. Well, it goes from negative infinity all the way up to positive infinity. So in this case, it's negative infinity to positive infinity. So now we're going to move on to function operations. So you're going to see notations, and we're going to try to break that down into easier to understand components. So anytime you see f plus g of x, that means you're going to take f of x and add it to g of x. Anytime you see f minus g of x, that means you're going to do f of x minus g of x. Also, when you see f closed circle, now there's a closed circle and there's an open circle. So when you see f closed circle, g of x, the closed circle means to multiply. That means I'm going to take f of x and multiply it by g of x. Well, guess what the next one's going to be? F divided by g of x is the same as f of x divided by g of x. And then lastly, g of f of x. Now, I want to point something out. Another way you may see this written is g of f of x. So they mean the same thing. Whenever you see that notation, they mean the same thing. So what this means is you're going to take f of x and you're going to use that in place of any x you see in g. And we'll talk about that more. So you always evaluate inside out. Inside goes into the outside equation. Let's look at our first example. F minus g of x. Remember that that means we're going to take f of x and we're going to subtract g of x. Now, you'll notice right here, when I write it, I put both polynomials in parentheses. And here's why. Okay, you always want to put both polynomials in parentheses when you're subtracting, because look what happens. What we did to go from step 1 to step 2 is we changed that to be plus a negative, and then we distributed the negative. Now it's simply a matter of combining like terms. So negative 3x and negative x get combined, and negative 5 and negative 2 get combined. and that gives us x squared minus 4x minus 7. Now, if I want f minus g of 2, then that means that I'm going to take this 2 and sub it in here. So that gives me 2 squared minus 4 times 2 minus 7. So that's 4 minus 8 minus 7. So 4 minus 8 is negative 4. Negative 4 minus 7 is negative 11. Now, if you didn't have to find the function first, if they just said find f minus g of 2, you could have done g of 2 is 2 plus 2, so that's 4. And then f of 2, well, 2 squared is 4, so this would be 4. 3 times 2 would be 6 minus 5. So that would be negative 2 minus 5, which would be negative 7. So I would have negative 7 minus 4, which is also negative 11. So it doesn't matter if you plug it into the simplified function or you plug it into each and then you subtract the results. You're going to end up with the same answer. Let's look at example 2. Example 2, that says f times g of x. Now, if you'll remember, that's the same as f of x times g of x. So that means I am going to multiply x plus 1 times x minus 1. So you can box this or you can FOIL it, but you end up with x squared minus 1. Now, what if I wanted f times g of negative 3? Well, I would just plug negative 3 in for x. So, negative 3 squared minus 1. That's 9 minus 1, which is 8. Now, let's say you weren't asked to find the function, but you were asked to find f times g of negative 3. Well, I would do negative 3 plus 1, and then negative 3 minus 1. So that gets me negative 2 times negative 4, and you see that I still end up with positive 8. Ooh, my favorite, composition of functions. Let's look at this one. So they want me to find f of g of x. Well, do you see right here that this is g of x? The inside function is g of x. And what does g of x equal? It equals x plus 2. So what I'm going to do is I am going to replace g of x with x plus 2 because they are equal. So what that means is anywhere I see an x in f of x, I'm going to replace it with x plus 2 so that it looks like x plus 2 squared minus 3 times x plus 2 minus 5. Now, here's something you always want to remember. Anytime that you see a parentheses squared, so anytime you see a parentheses squared, that always means, hey dude, write me twice, okay? So this is just showing that I subbed in those values. But anytime you see a parentheses squared, you're always going to write it twice. So you just have to kind of start thinking that in your head. Parentheses squared means, hey dude, write me twice. So that's why I have x plus 2 times x plus 2. Then you can FOIL this or you can box it. It doesn't matter. But you end up with x squared plus 4x plus 4. And then what I did here, you'll notice, is I changed this to plus a negative. And then I distributed that negative 3 across so that I got minus 3x minus 6 and then minus 5. Now, from here on out, all you have to do is combine like terms. Well, I see here that I have a 4x minus a 3x, and then I have a 4, a minus 6, and a minus 5. So that's going to be x squared plus x, and then minus 7. So that's a composition of functions. Now, if I want, remember this notation down here, this is the same as f of g of 2. Okay, so that means it's the same as the function above, it's just a different way of writing it. So that means I'm going to plug 2 into that equation. So that gets me 2 squared plus 2 minus 7. So this is 4 plus 2 minus 7, which gets me negative 1. Now, if they hadn't asked you to find the composition of functions first, you could have gone up here and said, okay, I need to figure out g of 2 first. So g of 2 equals 2 plus 2, which is 4. So this is equivalent to f of 4 because g of 2 equals 4. And then I just take 4 and plug it in. Whoops, I wrote 2. My bad, I apologize. So I plug 4 in. So 4 squared plus a negative 3. I just changed that to a negative 3 times 4 minus 5. Okay, so that is 16 minus 12 minus 5. So 16 minus 12 is 4. 4 minus 5 is negative 1. So it doesn't matter if you plug it into the inside function and then plug that into the outside function, or if you find the composition and just plug it into the composition. Both ways are going to give you the correct answer. All right, now let's look at given f of x equals 2x over 3 and g of x equals 1/2 x. I want you to find f of x. So looking at this right here, does this problem even ask for anything about g? No, it does not. So I'm just going to cross it out. It's just put there to see if it can trick you. So what we're going to do now is, do you see how f of x is equal to 2x over 3? So I'm going to replace this f of x with 2x over 3. So what this means is I am taking f of x and plugging it back in to f of x. So let's see what that looks like when we plug it in. So remember, this was originally, this piece right here was originally my x. So it was 2x over 3. But x is now 2x over 3 as well. So this guy, he gets put over 1. And that gives me 4x over 3 over 3. Well, I can write that as a prettier division problem as 4x over 3 divided by 3 over 1. So dividing fractions, don't ask why, flip the second and multiply. So I come up with 4x over 9. Now, if they want f of 3, that just means I have to plug 3 into that. So 4 times 3 is 12. And 12 over 9, that reduces by 3 top and bottom, and I get 4x over 3. Now, let's look at another problem. We are going to find f plus g and f minus g. So these I want you to stop and do on your own. So I want you to do f plus g and then give me the domain as well. And then I want you to do f minus g and then give me the domain as well. So pause the video, try this on your own, and then when you're ready, unpause it. All right, welcome back. Let's look at this. F plus g of x, when I simply add the two functions, I get 2x squared plus x minus 5. And it's a quadratic, and your domain is always all real numbers. So your domain is negative infinity to infinity. F minus g of x, well, don't forget when you subtract, you change the sign on the x, and then the subtraction of 3 becomes plus 3, and you end up with 2x squared minus x plus 11. And of course, that is a quadratic as well, so your domain is negative infinity to infinity. Because negative infinity to infinity is basically all real numbers. They mean the same thing. All right, example 6, given f of x equals 2x minus 5 and g of x equals 3x plus 8, I want you to find f divided by g of 5. So remember, f divided by g of 5 means the same thing as f of 5 divided by g of 5. So the first thing I'm going to figure out is f of 5. So 2 times 5 minus 5. So this is really saying f evaluated at 5 is equivalent to 2 times 5 minus 5. Well, 2 times 5 is 10. 10 minus 5 is 5. Let's try g of 5 now. So we have g of x, and then I'm going to plug 5 in for x. 3 times 5 is 15. 15 plus 8 is 23. So when I go to write that, I can say f of g of 5 is equal to 5 over 23. All right, last example next. Example 7. Given f of x equals 6x and g of x equals 2x, I want to find f of g of x. So remember, that's f of x over g of x. Ooh, but look what happens. I have an x on top and an x on bottom. What happens there? That's right, they cancel out. So I'm left with 6 over 2, which is 3. So if I ask you, what is f over g of 4? The answer, well, if I sub 4 in for x up here, but wait, there is no x. Okay, so since there is no x, it's going to be a horizontal line. So it's going to be a horizontal line that goes through 3. So all of your y's are going to be 3 no matter what your x is. So when x is 4, y equals 3. And this concludes day 3's lesson. You'll now go back to your assignment and you will complete your day 3 worksheet. So worksheet 1.3.